Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph a rational function when we have to use slant or oblique asymptotes. So basically what we're going to do is just follow the exact same patterns that we've gone through so far in this long little course. And I'll try to make it as quick as possible to go through this. So basically the first thing we want to do is always test for symmetry. So remember, when testing for symmetry, basically all you're going to do is substitute in f of negative x. And if you get the exact same function back out, then you have symmetry about the y-axis. If you get the negation of your function, then you have symmetry about the origin. So any negative value raised to an odd power is still going to become negative. But then that's plus 1. This becomes now even, and then minus 2x. So unfortunately, we don't have the same axis. We don't have the same function nor the negation of the function. So therefore, we have no symmetry. All right, next thing we're going to want to do is identify the x and the y intercepts. So to identify the y-intercept, basically all we're going to do is replace x with 0. So therefore, we have f of x equals 0 cubed plus 1 equals 0 squared plus 2 times 0. Therefore, when I multiply 0 squared plus 0 to 2 times 0, you can see that I'm going to have 0 in my denominator. So it's 1 over 0. So you cannot divide by 0. So therefore, there are no y-intercept. That means this graph does not cross the y-axis. Step number 3. Now we're going to check for our x-intercepts. And our x-intercepts is when y equals 0. So now, if x represents our y, instead of using y, we're using f of x. But we're going to just replace this with 0 and then solve for x. So basically, to solve, when you have an equation set equal to 0 and it's a rational equation, basically you need to get the x's off the denominator. So I'm going to multiply by the reciprocal on both sides. Oops. Therefore, I obtain 0 equals x cubed plus 1. Now, I'm going to go ahead and solve. So I have negative 1 equals x cubed, and take the cube root. So the cube root of negative 1 is going to be negative 1. So the x-intercept is x equals negative 1, which let me double check. I can't remember if I had that actually or not. Yeah, OK, I was right, negative 1. OK. So next step is to find the vertical asymptote. Vertical asymptote is when we set our denominator equal to 0. So in this case, we're going to have x squared plus 2x equal to 0. First thing I notice is I can factor out an x. When I factor out an x, I'm left with x plus 2 equals 0. Therefore, by using the 0 product property, I can now say that x equals 0 and x plus 2 equals 0. Solve for x. I have x equals 0 and x equals negative 2. So those are going to be my two vertical asymptotes. As far as horizontal asymptotes, we see that so for my horizontal asymptotes, we know that there's no horizontal asymptote because the degree in the numerator is larger than the degree in the denominator, right? You're looking at your degrees. When the degree in the numerator is larger than the degree in the denominator, you don't have any slant asymptotes or horizontal asymptotes. So if you don't have any horizontal asymptotes, the best thing to do now is look for slant asymptotes. So to do that, basically what we're going to do is we're going to use long division to divide the denominator into the numerator. And whatever the quotient is going to be your equation for your slant asymptote. So I have x squared divides into x cubed. X times x squared is x cubed. X times 2x is going to be 2x. Subtract down your rows. And what you're left with now is, let's see, negative 2x and then plus 1. X squared. Oh, that's a negative 2x squared. Sorry. X times 2x is 2x squared. So since I'm subtracting that, I should put it in parentheses. Since I'm subtracting, there's no x up here. So 0 minus 2x squared is going to be negative 2x squared. X squared divides into negative 2x squared a negative 2 times. Negative 2 times 2x squared is going to be a negative 2x squared. Negative 2 times 2x is going to be a negative 4x. However, those are going to divide simplified. That's become a positive 4x. But x squared does not divide into 4x. So that is going to be a remainder, which we're not going to be concerned about a remainder. We're only going to be concerned about is our quotient, which is x minus 2. So our slant asymptote is y equals x minus 2, which is going to be a line. OK. So just want to make sure I had everything correctly. All right, so now let's get into graphing our information here. Kind of running out of space. This is a little bit extra work here. So we have no symmetry. We don't have a y-intercept. We have an x-intercept at -1. We have vertical asymptotes at 0 and at -2. Let's go a little bit farther out. Let's say -1's here. Then we have a horizontal asymptote at slant asymptote at y equals x minus 2. So I'm going to go down to 2. And then the slope is up 1 over 1. So if here's my y-intercept, up 1 over 1, up 1 over 1. OK, so now basically what we want to do is determine the points that are now going to be to the left and right of each of those vertical asymptotes. So we already know what here. So basically what I'll choose is choose the points 1, 3. I already know it's 0. I already have 1. So maybe I'll want to do, that's not going to be fun. I guess I can just pick a point. I thought I had -1. Yeah, I guess I'll just have to pick a point. All right, I'll just pick a point, and then I'll do -1, -2, -3, and -4. So basically, I'm going to want to figure out what is f of -4, what is f of -3, what is f of 0.5, and what is f of 1. And what is f of 1, 2, 3? And what is f of 3? So I got to figure out all these values to help me graph it. Otherwise, you could just look at a calculator and also determine that. So to plug in those values, so I have -4 raised to the third, which is -64, plus 1 is a -63. So I have a -63 over. 4 squared is 16. 4 times 2 is 8. So it's 16 plus 8 is 24. So I have a -63 divided by 24, which is -2.6, approximately. Then I'll do -3. So the -3 would be a -27 plus 1 is a -26. -3 squared is +9 minus or times 2 times -3, which is -6. So divided by -3. So -26 divided by -3. Oh, 16/8. Wait a minute. No. 9 minus 6 would be a +3. That's going to be 8.66. So if I was going to go ahead and graph that, so at -4, 1, 2, 3, 4, I'm at a -2.66. At -3, 1, 2, 3. OK, let me double check that work. Oh. -4. Oops, I did this wrong. 16 minus -4 times 2 is 8. So it'd be -8. So it's 8. It's not 24. I don't know why I came 24. That's 63 divided by 8. So -63 divided by 8 is -7.8. 1, 2, 3, 4, 5, 6, 7. So that's going to be down there. And then at -3, we're at -8.6. So this graph is going to be like a little U. It's going to approach this asymptote and approach that asymptote. Now it's going to do 0.5. So 0.5 raised to the third power is 0.125. Plus 1 is 1.125 divided by 0.5 squared plus 1 is 1.25. 1.125 divided by 1.25 is 0.9. So at -1, x-intercepts -1, at f of 1/2, oh, shoot, I was supposed to do -1/2. Crap. We already know what 1/2 is. I need to do -1/2. So it'd be -0.5 raised to the third power. Plus 1 is 0.875. OK, and then that's divided by 0.5 squared minus 2 times 0.75, divided by -0.75. So it's 0.87, no. 0.875 divided by -0.75 equals a -1.66. Approximately -1.66. OK, got that. Now let's go and do f of 1. So -1.66 would be like down here. And therefore, we have this. So it has to approach this asymptote, has to approach that one. So that's going to take a cubic form. You could also do like 3/4 to determine what that one will look like. For f of 1, though, let's try to get this a little bit quicker. 1 cubed is 1 plus 1 is 2. And then 1 squared plus 2 times 1 would be 2, plus 1 would be 3. So that's 2/3. So at f of 1, I am left with 2/3. And then f of 3, that's going to be 3 cubed is going to be 3 times 3, which is 9 times 3 is 27 over 28. And that would be 9 plus 6, which would be 15. So 28 divided by 15 is 1.86. So at 3, I'm at 1.86. So you can see, again, this is going to take that shape. So I know, ladies and gentlemen, it kind of takes a while for me to go through all these values. But it's very important for you to be able to know how these values, how to create your table. Because you might have a calculator, you might not. You want to make sure you can evaluate to find those points. All right. For the next one. So I'll try to do this here really quickly. Actually, what I'm going to do is I'm going to test symmetry on my own. And if I look at this, if I plug in symmetry, -x, that becomes negative. But that doesn't change. So therefore, there's no symmetry. Step number 2, the Y-intercept. So I'm going to plug 0 in here. So the Y-intercept, when I plug 0, what I get is y equals 1/9. X-intercept. I plug 0 in for x. And therefore, multiply that. I get 0 equals x cubed minus 1. Add to both sides. Add 1 to both sides. So I have 1 equals x cubed. Take the cube root. Take the cube root. X equals 1. So I have an x-intercept at 1. And y-intercept at 1/9. Number 4. I need to find the vertical asymptotes. Vertical asymptotes, you set your denominator equal to 0. X squared minus 9 equals 0. Use difference of 2 squares to factor this. Therefore, x equals +3 and x equals -3. Those are both asymptotes. I can verify there are not going to be any holes. Next thing is horizontal asymptotes. You know that the denominator is smaller than the numerator, so there's no horizontal asymptote. So now let's try our, so horizontal asymptote is none. Slant asymptote is going to be x squared minus 9 divides into x cubed minus 1. X squared goes into x cubed. X times x squared is x cubed. X times -9 is a -9x. Subtract the rows. This becomes 0x cubed. 0 minus a negative 9x is going to become, or minus a negative 9x is now a positive 9x. However, x squared does not divide into 9x. So my slant asymptote is y equals x. So let's go and graph this one. Again, there's no symmetry. We have a y-intercept at 1/9. We have an x-intercept at positive 1. We have vertical asymptotes at positive 3 and negative 3. So 1, 2, 3. 1, 2, 3. And we have a horizontal asymptote at y equals x. OK, well, we have 2 points here. I can kind of decide here that that's probably going to take the form of a cubic. And now I need to pick 2 points to the left and pick 2 points to the right. So my 2 points to the left are going to be -1, -2, -3, -4, -5. So I'll do f of -4, f of -5. And then I'm going to pick 1, 2, 3, 4, 5. And then positive 4 and positive 5. All right, so now we just need to plug them in. So 4 cubed is negative 64. Minus 1 is a negative 65. Divided by 16 minus 9 is 7. Negative 5, Negative 5 cubed is going to be negative 125 minus 1 is negative 126. And then 5 squared is 25 minus 9 is going to be 25 minus 9 is going to be 16. Let's do 4. 4 cubed is 64. Minus 1 is 63. And that is going to be over 16 over, so that would be 7. And then 5 would be 125 minus 1 would be 124. Divided by 4 squared. That's 7. Oh, that's, wait a minute. OK. 4 is 63, or 64. Minus 1 is 63. Then this 16, so that's over 7. Good. 124 would be 125, would be minus 16. OK. So now let's go and get the decimal approximations for these. So I have a negative 65 divided by 7 is approximately negative 9.2. Oh, let's round. Negative 126 divided by 16 is negative 7.9, or approximately negative 7.9. 63 divided by 7 is 9. I guess I should have known that. And 124 divided by 16 is 7.75. All right, so let's go and plot these points now. So at negative 4, here I have negative 9.3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 4, I'm at negative 9. And at negative 5, should look something like that. I should curse it in there. Then at negative 5, 1, 2, 3, 4, 5, I am at negative 7.9. Be right around there. So this is going to fake that shape. I know I don't really have the best graph here. At 4, that's going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And at 5, it's going to be 7.5. So I know it's really hard with my graph, but when I go ahead and verify my answers, that's what your graphs are going to look like. I just don't really have a graph paper, so I'm just doing the best I can. But there you go, ladies and gentlemen. That is how you graph rational expressions or rational functions with oblique asymptotes. Thanks.